In the previous session, I have explained the assembly language program to count the number of ones and zeros in a given 32-bit number and store it in consecutive memory locations. In this session, I am going to execute the program stepwise. So first, right click on the file and click on build target. So you can see here there are no errors. Click on debug and we need here the memory window. So click on view and select the memory window, and we also need the register window. So click on view, then click on register window and give the input in the memory window. So I will give the input, so that is the 32-bit number, and I will store the lower order byte at the starting address. Seven A 5 6 3 4 1 2. So here 32-bit number considered is 1 2 3 4 5 6 7A, where the lower order byte is stored at the starting address, that is at the first memory location, and at the fourth memory location higher order byte, that is 1 2, is stored, and in the next consecutive memory location the number of ones will be stored, and in the next memory location the number of zeros will be stored. So let us execute this stepwise. So first you can see here the starting address, which is stored at the memory location, is going to be loaded into the register R0, and the 32-bit number which is stored at this address, that is 0x4 followed by 7 zeros, will be loaded into the register R1. And next you can see the content of register R4, so that is the rotation count. So the rotation count is 32 and its hexadecimal equivalent is 20. So 20 will be stored at the register R4. And from the previous sessions we know that when the counter, that is R4, becomes 0, all the rotations will be completed. So, and we see here, we will see that by executing it stepwise until R4 becomes 0. So now you can see here the content of R4 is 0. That means that all the rotations are completed. So after the rotation count becomes 0, address will be incremented by 4. So now you can see the content of R0, that is 0x4 followed by 6 zeros followed by 4. So at this address we are going to store the number of ones in the given 32-bit number. So you can see here the number of ones at this address is 14. So that is its hexadecimal equivalent is E. And in the next consecutive memory location, so we need to store the number of zeros. So let us see that by executing stepwise. So you can see here the number of zeros in the given 32-bit number is 18, whereas its hexadecimal equivalent is 12, that is 12.